short video. I've got one coming up. I want you guys to watch it. It's a deal with a rebar. This is the essence of pretty much all current day engineering has to do with rebar and concrete. At one point, you can have a steel structure. You're still going to have steel floors put in, concrete reinforcement having to be added. I guess you can get around it with some pans and some studs. But I want you to take note of this photograph, this imagery from here. And that ramp is what I'm going to talk about in a couple of videos, but I don't show you the photograph. This is the photograph that I'll be talking about, or the imagery rather, I want you to perceive or understand. This is, I don't know when this was taken, but this is the concrete material, different than the asphalt material. It looks like concrete, and then like a ramp, and then up. I talk about the truck backing up and bumping this corner. See how this turns and goes that way? That turns and goes that direction. Let's see if I can do this. So this goes this direction. Let's get red. Okay. So it goes that direction there. So it looks like this, this, and this. Let me move it. And the car is parked here, the truck. Well, I play devil's advocate, and I talk to you about it jokingly, not jokingly, but devil's advocate for real, about what happens if the truck were to hit that. Could it cause the structure to rotate, this to rotate, put a stress along this crack line here, cause it to stress, creating a fulcrum and causing a rotation, if you will, of this going down into the deck. I ran it. I don't think that happened, but, you know, I show you that I think about all that stuff. This is the gate here. The gate is here. This is the butterfly. Okay, so let's remove it. I'm going to now show you what the column is right about here. That's where you see it presented up. Well, it's actually way down here, but I don't think you'll be able to get it. I want you to be able to visualize it from this gate here. This is where the gate parts. It's a fracture that's not, it's a brittle fracture. It's very abrupt, very sharp. This appears to be aluminum. So that's one hell of a fast, abrupt force. I've evaluated that crack on this metal here, on this part of the railing. I'm not going to do it in this video. I've already evaluated that crack. And from what I can tell, I wish we had closer imagery of it, but it appears to be a squared off pretty damn good. Now, I wouldn't say it's a weld. I wouldn't say it was butted. It just looks like a fracture. Okay, let me go with that now. Let me talk to you about that just now. So this goes this way, back. Pay attention to this. This comes across. This I talk about in multiple videos. I don't know if I put it here on Rumble already or if I even loaded them up yet. But you're going to get the short version of it, so you have to remember to put it all together. This is at one point where you see people look over. This is this railing's here. This railing will be the railing's here, but this railing will be removed on this. Let me just put it this way. Let's get rid of this. Let's do this. Let's go here, 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 and now I want you to put this planter box. I want you to look at it this way, and I talk about it in the drawings in the video coming up. I think it's on the 16th, maybe 20th, maybe already posted on Rumble. But I talk about the rotation going down this way. I choose that rotation because we have bushes here. If this were to rotate this way, the box, it would have pushed the bushes back against there, and we would have seen concrete here. I've also alluded to in many ways about a column over here that I talk about. The column is really, I believe, what you see is this section here, hanging from over here. So if you look at the videos or the imagery of the collapse, you'll see that there appears to be a piece of column right here hanging from this box right about here by the tailgate of the truck with the ladder in it. So the rotation, why do I choose the rotation this way? If I choose it the other way, this railing is integral. It would have pushed the wall out. Oh, wait a minute, we do have a moment of being pushed out there. I believe that moment is created by this one, combination of this one. Okay, one of them is greater than the other, and that's during the failure. During this rotation failure, it does that bump, like you push your hips out, bend over, and when you bend over, if you will, you push your ass out. Well, this is the ass, if you will. It pushed it out before this deck went down, and then it changed the directions. It changed the directions of that of the rotation. I talk about in the other videos how this this planter box here, the back side of it, is clearly the planter box is inside here now. Inside here on top of, and let's look at it from bird's eye view, there's grass on this side and grass on this side. The bottom of this box is on top of there. So that means this side of the deck went down first. All right, it went down first, and the delay happened. Delayed, isn't that a time delay? Anyway, the delay happened. During that, the rotation happened, and also the redirect. So this is responsible for the redirect also of this bottom box being put here. This is. We need a moment to rotate it. And we can do good luck. And you know, luck that the column, when it went down, it just rotated and spun around that way. We can go for that. That would get us the rotation, right? And so it would be reversed. So this is going up. We get a fracture. The deck's going down together, so not here first, but sort of together. All right, so let me see if I get this right. All right, so here's your column here. So as it goes down, this gets lifted up. When it gets lifted up, it pushes, so the wall goes back to here. It pushes on that wall, and remember the deck is going down. As it goes down, it's still integral connected with over here, and this appears to be non-solid right here, if you will. I'm sorry, this is non-solid with this one, integral. Let's get this together. So that I think there's one is a little bit lower than the other. I think this planter box is lower than this planter box based on the railing system. The railing is about equal with here. I'll reveal that in just I better reveal it now. All right. So the railing is higher. I'll show it to you in a moment. The railing, you see the railing here, right? This railing right here sitting on top of the box. Its continued height goes down to this corner, turns, and goes this direction. As you can see, it's about equal with the top of this box. So we have a box that's a little bit higher over here. I don't know when they put this in. I couldn't find it on the plans that it was ever supposed to be in there. So obviously vehicles can back up, but they're stopping. They don't keep going and slam into the wall. Depending on how it was anchored to this deck, if it was rebar reinforced, yes, that would create a torque in the deck. Otherwise, you could probably slam into this for free and just fracture the wall. Over here is where it might create a rotate of stress down in here. Might. Even without rebar. I doubt it though, because it would have to be like that. And I don't see the truck, even a truck hitting there would create more like a shearing action across this wall. Pulling on that one, pushing on this one at the bumper level, the contact point level. I have seen many of cars run into walls, and it's usually just as I described. Now, so you get this going down. Instead of it's going down, it's on top of the column. It does that when deck goes down. It pushes against the wall here. I give and I take. So in another video, I played devil's advocate for you and showed you a different version. I think on Rumble, or maybe it's yet to come. But you're going to get the end video right now first. I'm going to present it today, which is Saturday. And that way you can watch it with a bias now. When you look to my content, you're like, wait a minute, but I kind of like this version of it. And I think you may. So as it goes down, it lifts up this box. But when it lifts up this box, right? So there's a box here. All right, this box is this shape. So pay attention, you engineers out there. This box is this shape. What happens if I push, that's the column, if I push this box up? Well, it's a cantilever arm, isn't it? It's an arm. And where's the reaction point? Well, the reaction point is going to be here, and here is what I'm picking at, because the box is not fractured. We don't see the box fractured in between besides where the column is. So as it goes, the deck goes down, this creates that moment to bump this wall outwards. Once it does that, we also get a fracture here and a rotation. That rotation, after this has cleared the column head, the column head over here, the shear head, that rotation to get this planter box in this direction is caused by this rotating downwards. Now, how do I get that? Watch, that's that steel, right? The railing. Let's get there. So I don't want to save this. So this, and don't save, and I go up 2. So I'm here though. Dawn Lehman's thing we already went over in the other video. She states that it's under the gym floors where it starts, and I show you the content where the ledge is over there. It's reinforced in that direction. It's not the weakest point. All right, so right here is where I get to that for you. That's the railing. This is pre-corruption. In other words, pre-corruption means before the firemen start moving around things, not on purpose. But take note of how this is in line here. And this is not in line. This is off. And I know it's not in a hole here or here because looking at images from the other directions, I can see it's already popped out of a hole there and there, probably a lateral fracture. I said I evaluated the cut of the railing over here. Not in this image. Oh, there it is right there. Well, it also looks like that. So when you look at the break, it appears this railing system is, you put it together and you've probably got an internal snap of a clip type deal. Nevertheless, you see that see the rotation here? This is rotated out and around. So this is rotated back. This is how I choose that deck. This is like this. It's rotated around like this. So now that was connected there. The planter box is on top of it. The planter box is here. As it rotates down, this going up, this creates that moment where it's in the air. Also the reaction down at the back of the deck, which gets us a little push here on that wall that we see where it's bowed out. And then we get on the jealous wall. And then the planter box rotates down. We get the forced rotation of this at the same time, putting it held up for a moment. Remember, it held up for a moment, but it also cantilevered down before it let go. This is what causes a huge fracture in our deck along that line. And then it released, dropped down, and this is our position. It's sort of like this. And like that. So wait a minute. It's like this now, right? So there's the box. There's the railing on top. Okay, let's put that back this way. This end of the railing is down here. This is down here. I'm exaggerating, showing this lower than there. As you can clearly see, this is the top of the shear head, and this is lower than the wall. Shear head is equal with about where the deck was, about 9 inches. We're seeing about 9 inches right there. If we're from the parking garage, we would see all white up to here at least, and possibly maybe that's concrete engrossed there. Okay, so that's how you get this wall pushing out. There's the railing hole here, pocket here. See the pocket for where the railing was? I'll show you that in the 2 images. Oh. Okay. So don't save. Right here. So there's the railing turning this direction. And right about here is that, So right about here is that little bend fracture. And then the other one's down here, probably, you know how they manufacture it, put it out there, transport it on vehicles, however they put this together. I don't believe it was welded. It seems to be like a electrolysis dip product, yeah, although it's aluminum. All right, so then the railing we see is not this one. This is not presented to us, nor is this presented to us. It's gone. Let's delete that. So part of that rotation and rotating away, I believe rotated this direction, rotated that direction, gets us our ripping, and I base that on this this railing here is now this. It looks like that, right? It's turned back. So how do I get this point, this connection right here? How do I get it from there to here? How do I get it from there? Oh, well, it's a little bit further in, maybe about there. So how do I get this railing right here over to here? It was connected here. And I'll also get a fracture here, a bend and a break and a bending moment in the air. See, in the air. So the only thing connecting that would be, in this wall being where it is, to be able to get that much rotation out there, well, it would be this wall. And that's why I choose this wall to be a rotating wall. I choose it to give us our interactive elevation changes of the where the placement of this is. I also choose it why we can get that bump outwards, and then as it goes down, the interactive connections of the concrete here. This is still connected down here to here. There's a little bit of a railing action going on, but you can see what it presents to me as the inside of planter box, the waterproofing, but kind of weird, like it stops here. That's the 19-inch opening, I think, that 19-inch opening. And when you see the fireman images from this angle, you'll see like two panels laying on the floor, and it appears these dissimilar colors from this coloration might be this panelized wall, if you will, that was able just to rip off the deck. I don't have that image handy, and I wanted to keep this video kind of sweet. In other words, kind of short, and that's pretty hard for me to do, as we know. What's below it, if I can find it? All right, so yeah, there's your box there, the view of it, the rotation around. There's the box, and there's the reinforcement. The panel system here being here like this. There's the wall that when it rotated down, this is that part. If I could sit this up, would be back on this wall here. You can see it's part of the ledge system. I know in the photographs, everybody's trying to read through the photographs on multiple sites trying to read this wall. You can't read this wall anymore. Once they tore this down, they did a whole nother dynamic of that system over there. It's not the evidence that we can observe. It's corrupted, as I call it. They tore it out. It's a whole nother look over there. The rebar that's exposed over here, it's a corrupted system. The wall system is very critical here. It tells you that this was not just cantilevered up. If a wall is on top of the considering a wall on top of, that's the wall. That's this 5-foot wall, let's call it. Whatever code allowed, change it to. And here's the pure sheet pile system and the 8-inch wall. Let's just stick it out a little bit. Here's the pad. Here's the concrete pad over to the columns. I don't know if it'll draw that. Yeah, I'll take it. All right, so there it is there. The wall's on top of it to some degree. Maybe not fully. Maybe it's like that, and then there's some mortar back here. I don't care if you put it all, a little bit more. The point is that when this goes down first, it's not for free. It creates a prying action in this wall here, and you would see it fracture. But there's also another point where it could fracture, would be here, because that's a point where if you're dropping this down, this would want to fracture here. That fracture would not be so clean. It would be probably more like a exaggeration like that, but it might be more like that. To be like that would be amazing, because there's nothing on top to create the fracture. It would be more like that, tapered back where it's touching, but the resistive force is just a block wall, so I don't see that, and we don't see it reacting on that wall, meaning lifting it up. Over here on this wall over here, we do see that right here. It's a bump out, and then this wall gets closer here at the foundation, closer over here. Oh, there it is over here. Let's move that away. See from this view, see that little dark area, shaded area there? That's actually rebar reinforcement exposed. And it tapers down, thins out to right about there. And on the side, it thins out to about there, being widest here, and this location here where this rotation took place, the bump being here, the block where firemen are and the policemen are that night. We see them shoot the photograph with the light on the wall. That's your rotation. So we get our box fracturing, rotating off. We have the reinforcement going into this wall like this, theoretically, supposedly, per the plans. and they're every 12 inches, 5/8 rebar. I have another video coming out talking about rebar pull-out test, so we'll go over how you can get that to look. I mean, literally, we need to match what we see, not just say this is what it is, period. No, we still got to adjust to whatever we see. Again, it was in place. These photographs, we would need photographs before they remove the shrubs. Someone would have taken the photographs back here. Once we see it from that point, it's corrupted. We don't know what this looks like over there because they went at it with a bull in a china factory with the excavating equipment. So, and that was dynamited, right? So this creates, you just don't get this for free. Drop this down and just fractures here because the stresses are here. No, it still want to act like a pry bar and lift up on this, right? We have no pry bar action. I'll leave that for another video, but I think you should be able to figure it out by now. So this didn't go down. This is what we have. Let's move this out of the way. Oops. Let's move this out of the way and just do the deck type action. Okay, there we go. And we'll take some liberty and not put it all the way back. Or if you put it back more, it still has to have that fracture here. Let me get this right. So it would be like that, or it would want to react over here. But nevertheless, it would want to lift this wall up. This wall does not look lifted, or it shows no signs of having that. So I think it was more of a tension failure as this deck, I wish I could show you, went down from the column over here. It pulled away. So it went down, it pulled away, and it actually hopped away. So it was a chronic, a spontaneous, what's the word I'm trying to find? I don't want to say critical fracture. It was a abrupt, oh gosh, I know the term I'm trying to come up with. So it happens instant. It's a drop off. It looks like this on a scale, and then just drops off. So it's right here, and this drops off. So it took some tension, and then it bunny hopped. It went as far as that, and then it dropped down. Interesting, when I say bunny hop, it was a tension like an elastic tension that was released. Now I don't have it actually literally moving over like this, the deck. I have it going down, because if it moved over, it would have fractured the columns. I can't find close enough. And when I say fracture, hairline fractures would have possibly shown themselves laterally moving against this. This is not identified there, so we have this failure in the middle through mid-span puncture shearing through there. Gets us our dip. That puts the stress in the rebar here. And that, in turn, allows for it to pop a lot easier. Now, it does a bunny hop because there's no scratch marks. Yes, there's scratch marks after they take this all apart, but it matters before they take it apart. Even after they take it apart, though, if you look closely at a couple of images, you'll see no scratch marks here, indicating that the rebar was still sticking out like this. Let's do that. So I'm going to do an overlay here of the rebar. So as it went down, it scratched the wall right there to the left. No, they're not there. So this appears to be what I'm going to show you in the pull-out rebar test, how it fractured. You'll get a clean break at that point. You get a little necking and then a fracture. But it happened so fast that you got both of them all at the same time across the panel of a few of them over here. With the holes in them. The others I can't tell because this was, again, moved by excavating equipment, so it's a different dynamic how they went at tearing it apart. The one more thing to give you, and that right here, right below is where I'm saying they didn't push over. Oh, it's remember the core samples, so don't get distracted by all of the circuitry here. The core samples were fractured with the rebar right about there, let's call it. And this was not engaged. The rebar was not engaged. This is at the drop slab area, so the deck is here. The deck is here. And here we go. So this was not engaged at the rebar, the concrete. It did have more rebar in it, but we saw that the rebar here was fractured. Let's do that and then do another section below it. So it's not engaged. It's not working over there where rebar is not in contact. It's not working. I can make an exception real clearly of that. It would be my staples video I showed you, where I show concrete here, I show concrete here, and then I run a piece of steel, as you guys may have seen in the video. Maybe I'll tag it with this one, and I run what I call the exterior staple. Clearly these aren't touching, but this steel is engaged via this staple. Same thing here. Over here, but this was the end of the deck. Pretty much, I'm sorry, there's a correction to that statement. It was planter box. That's what I was trying to get to. Okay, so planter box, right. I want to show it like this. So the over here, KLM, M is here, and we're looking at it from a side view, like we're in the garage area, looking up, and we got X-ray vision eyes. This is where the core sample was taken. Let's just do that. So we'll give it a weird shape, and we'll call it the core sample. And this is the rebar that's no longer engaged. We're going to lift that up, and we will say that it went through, and we'll do both versions of it. One where it goes through and connects into the drop slab detail like this, and the other version where it somehow just stops there, and that the drop slab has other reinforcement. 90s, they have 5/8 inch L-shaped 90s going into it. We'll say this is not connected. With that said, those 90s, where did they go? How far did they go out? So they look like that, and they turned into this part of the slab. That I'm not making up. They really do have that part of the plans. So I have two choices on this rebar. Did they overlap these 90s and come over there like that? Normally you don't waste steel, and you normally don't. It didn't say double down. Right here, it would look like a zero clear, like a zero on it, meaning the two overlap. I did not see that detail. So with not seeing that detail, I would say it's spec'd like this, and then additionally spec'd with that. 1979, they did allow an offset of steel. You didn't have to run it, touch it together. Something I'm calling 6 inches and 6 inches and 6 inches. Oh, thickness. I know what I'm recalling now. Thickness of the slab, no more than the spacing of the rebar should be the thickness of your slab. So I know they have it spec'd at 12 inches apart. It's two-way slab. I'm trying to confirm that with all the research in my 1979 book, but that 9-inch slab should have been about 9-inch spacing. But they did do two-way. They did a lot of different things there. You can get through it through prescriptive formula, saying that, we engineered it to work this way. I did not see that because it didn't state that anywhere. Besides, it was on the drawing, so it's sort of stating it there. That's my caveat to that. Back to this. So this where they drill the hole in, talking about the columns, L and M, they drilled a hole in by each L and M column, the critical shear area. Remember, here's the column. Let's do that as a column. They're square, so I don't get the liberty to say that. So let's do two columns. So this should be the column, this is column L, let's call it. And let's do another one. Nope, let's do this. So then the critical shear area around this column looks like that, let's say it. Well, right here is where they drew, hold on, I'm going to move it over. They drilled in this area right next to that's the column. So right here, and this is the planter box also, roughly this looks about line with the critical shear area. They drilled a hole in here to put drain in it, and that's not acceptable to drill a hole over there. So they did that in the 80s with that engineer that did the floor, I think, and then they did it again, Long Tongue or something like that, Long Tongue. So anyway, yes, I'm doing it so you'll remember it. So here's L, and M is a mirror of this. So L and M are a mirror of this same deal. To the left of M was over here. Remember, they drilled an inspection hole. That inspection hole revealed the rebar was not engaged in the concrete. We don't know to what extent. They did one hole. He didn't keep tracing it from there to find out where it stopped. He didn't support it when he saw that. That was not a red flag for him to instantly put supports up. Well, it wasn't a red flag where they put supports up. How about that? And then, maybe it was secretly, I don't know. Then here is that hole. The planter box, the other planter box goes here. Let's just do it like this. It's going to overlay dark. Okay, good. So there's a setback here. This is the hole. Let's get rid of this. So this is the looking at this is the planter box with the grass on it, right? Shrubs. Okay, shrubs. Okay, let's just put them up there. As we look down, it's really grass, but imagine that there. So, all right. So it's really grass there, and that's that lower one off the deck. It's only about 6-inch curb. It's over here. It's only about a 6-inch curb, and then you come to the 11-inch elevation change. So at this point, there's another 11-inch elevation change, and that's that 12-foot 9-inch elevation. And the box is where you get your the patio of the people coming out of the 111 room. So 111, right? So let's just do that. So that's the lower part. That's M now. That's the hole. Let's bring that forward a little bit. That's the inspection hole. And there's the drain. So over here to the right is this hole here, the inspection hole, would look something like this if we now look at it sideways. I know at least at the inspection hole, it had the rebar broken away from it. At least at the inspection hole. So right here. And now let's just say it by chance, he just found the exact spot where he drilled a hole that it's only failed right there with that much. Well, there's going to be some ramp up and ramp down, if you will, of that fracture. So the deck is representing as deflecting there. Too bad we didn't measure the steel, but it's representative of a deflection. That deflection is not revealed. So in other words, not supported. My statement's not supported by the survey. The survey has it pretty much. The deck is profiled, looks like good drainage and everything else. The deck, the top deck, but he took his core sample from that. From this elevation, the top deck. He said he noticed a lot of cracked tile. That's very important because that could represent a lot of compressive moments in the deck, deflection, and identifying as pop tile. Could also be the guy grouted too tightly and expansion wasn't allowed for because I didn't see any expansion joints in this system. It could be a few other things too, but you can't read too much into it anymore. Besides getting data. So this is an exaggeration, but there's a ramp up and a ramp down. You just don't have it by chance that one spot broke unless you used a jackhammer and separated that concrete. I don't believe that to be true per the core sample's visual look that presented to us. So I'm exaggerating my ramp up, but let's see if I can change the ramp a little bit. So it would probably be a lot less than that if it was deflection. And all right, I'll just take it there. So I'm exaggerating with the ramp up, if you will, of the forces. So we don't have here a crack or anything, but why did he pick there? Is more to it than we know. We can't see why he picked here the core sample, but we can guess that he saw something that said, I want to sample here and the one over here by the garage. And he picked two of the spots that exactly had bad conditions of concrete and rebar engagement. I mean, he picked two perfect spots. Now, I would suggest that he's been doing it so long that he knows that he can visually see the part of the deck that he can get two bad samples from, and then encourage the owner that they need these repairs. I mean, you wouldn't take a sample over there by the concrete pool like Papa Smurf did. He knows that to be pretty strongly engaged over there. It's a short span. There's no deflection there. it wouldn't be an issue. So you don't go core sampling over here to try to say you need to replace a deck. You want to find somewhere where you know to be defective. Midspan would have been a nice one, but he didn't have to do that. He nailed 2 spots, here and there. They asked for additional core samples. This is the part where I would defend his position. He asked for them, and I think they had to negotiate back down to these two, an extra 2 or 3, less than what he wanted, perhaps. Of what I'm driving at. So back here, even though we see the fracture, it's representative of a deck, and it's too far over, just so you know, that's being flexed, right? Bing, ding, 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 like this. It's too far over here. I don't see that deck flexing, and we have no reports of anybody saying the deck felt springy, if you will, when cars came in, that no one's reported springy deck. So I don't have it springing over there. Nevertheless, he's over there to see all that sealing with all the water penetration, and he knows to take the sample here. The company does. When I say he. So he represents the company, maybe not. Maybe the company, either one. Doesn't matter to me. I'm using it inversely. So over here is where we already know that it's failing between L and M based on this sample. So we don't have to fight over did it start here, did it start there, like Dawn Lehman's wondering, saying the video doesn't support it. Well, she needs to add the this into the failure, that this was not capable of holding. In other words, if I try to do a pull-out test with that core sample, I would just use my hand and just throw it on the ground and be, okay, done. It's nothing to, there is no engagement with that steel. They were separate. The pull-out test is, okay, you got 0 forces needed besides holding the bar and, whatever friction it takes to pull it away from with 2 fingers, away from the other piece of concrete that was below it here. So using the pull-out test, you would see that it would be, nothing required. It's going to come apart easily. With that said, we have a location where it would fall easily. Using lens compression and her ladies zooming in, it would pull out here about 12, this is 11 feet plus this is approximately 6 feet more, and maybe another foot. So 11 plus 7, this section falling down would go all the way back to here falling down, which would be right about here. And then her lens compression would pull it in from here to bring it up to that column, meaning the column that's on line of the plane of the building. Because we have to deal with lens compression. We're not seeing where it really is. When she zooms in and you see that concrete and it looks like it's touching that column, it is not there. Lens compression, zooming in, would not let you do that. It would pull it in further. The larger one becomes even larger and pulls in. And so we have to have it back a little bit, pulling in. So we can pick your poison. You can have it breaking here from the drop slab and the deck staying intact. The deck here staying intact because the BMAs are intact across holding it. You can have it failing between the 2 L and M columns. Or you can pick it out here where this core sample was taken, and that's where it ripped over. But I still have it. I don't have that as the initiating path. I kind of do in one of my scenarios that I've never shared with you, that could be the initiating drape. But the problem I have with that is the filming of it was after they left, right? Let's go here, 5 to 7 minutes. She heard the big bang, it went down. Adriana, you'd have to ask her, did she hear 2 bangs or 1? What was the first noise that made her get up? Was it 2 or 1? Does she recall? So the lady, 111 near, ran over to the structure here, looked out and saw the cars had fallen down. She said the cars had fallen down. She went to go grab her family. She didn't say her deck had fallen down. You would think she would have looked over there, so close. Maybe she couldn't see it, but you think she would have looked over there. Nevertheless, she ran back to the apartment, met her kids at the door. She never entered, as she's never stated, and they left. He states, the son states that somehow he's observed it. He shows the butterfly with the 2 fingers, 2 hands down, and then how he said he ran to get everybody to escape, the whole family. but it stores a conflict, because how are you doing that when your mother went from here all the way to here, all the way back down the hallway and met you at the door? Already reported before he reported his version, that latest version of it. He's not come forward to debunk me on that. I would welcome him to debunk me and get clarity on that, because we would go with whatever story works out. So don't that's subject to change on all of them, except for the Nears. I think that she locked it in. She was under panic, but I think her versions are pretty. Her version, the Mama Bear, is pretty damn solid. She even thought it was an earthquake. Then we have the phone call taking place where she reports the deck down, Cassandra Bilodeau Stratton, and that takes that time. At that time, I think the filming is going on with the one lady, the Adriana. Filming takes place, and that I believe that includes, because you were looking at through here, includes this decking out to here, out to M, to the face of N, right where the core samples are, or up to here, and maybe not the BMAs at this time. Maybe not. I'm going to end the video with that, but you guys can use either version. I do not think it's this BMA here for sure. For clarity, I do not think it's the BMA here, with the caveat change of that. In the video, we see what appears to be you guys called it washing machine a long time ago. Now, maybe you understand it as the planter box, ringed around the M column. To ring around the M column, we need this BMA to go down. I am going to do a reveal in another video, not this one, where we're going to show the deck. I'll show you the deck. I guess I'll reveal it now. I'll show you the deck on the ground. All right, it's the drone. It's one of the images where they fly over, and the drone images, videos, and you clearly see they scraped the deck off. It's not fractured. It's flat. It went down as one. You'll see, well, this is a good piece of, right here, you'll see a piece of pipe sticking out, red pipe, and that represents the plumbing pipe under there, and it's underneath the top, and so on top of that red pipe would be the deck. The deck is in outstanding condition, meaning it just pulled away from the structure. I believe, again, the butterfly is where we're going to see the initiating cause. I do not believe they don't have videos of this. You can call it trolling, whatever. I just don't believe they don't have videos of this. They just fixed those cameras, and now all of a sudden they have no cameras, no camera imagery. All this, they have no camera imagery. It's craziness. Okay, that we get lucky. So here's the holes that I talked about where it's shifted over, but this time we don't see the railing in place. See, the railing's not in place there. There's the 1, 2, and 3 contact points. There's your planter box opening. Your 19-inch opening would be here, I believe. Well, this looks much larger now from here. Looks much larger than 19. That's questionable now. As far not questionable, meaning how wide was it? These are the scratches after they've already done work, did something over here, because this railing is now. See, it's not there. The railing's no longer there. There's the 2 off. But let's go back and show you the railing again. That's the railing shape, and then I have to go back, what, 1 more, 2 more, and then there it is, bent. Time of when they're still trying to get their heads wrapped around everything. Oh, there's a guy sitting here. Nope, not here, but this rebar goes way down. It gave it nice perspective on how far this rebar is over. It's parallel between the 2 columns. It's not shifted that way nor that way. Clearly the columns did not shift because they're pretty straight. Plumb. See how this rotated in? And now you won't see it there in the images a few up. This is what I'm talking about, how quickly images can be corrupted by, data can be corrupted by when you did it. So this is the generator time. When you put the generator out, someone's already removed this railing. So this image is now corrupted. There's the plate I talk about. See the wall system right here? Like that. That's one of the wall system. I said it like a plate system. But this is corrupted. You can't get too crazy about that. This is the umbrella. No machine on it yet. There's no machine on it yet. There's the plate. There is the bent bars. What What else can I give you? That was Josh's thing about, it's a two-way slab system. All right, guys, two-way, two-directional. This is two-way, but I have a problem with their two-way because I do pull-out test a lot with rebar and concrete. And I don't see how they could do, I don't like this system. I don't like this slab on top of shear head system. Without the drop panels, without capitals, without some steel bracketing, without being significantly large or some beam across it. I think it's the most dangerous system there is out there. This system without beams going across, isolating it. I've seen South American countries do better than this. And that was not an insult to South America. It means South America is supposed to be, more budget friendly more budget conscious than us. But it's conversely though, we're more budget, price than they. In a lot of places, South American, I meant like Philippines, things like that, not South American. So there's that offset, there's the offset again, this is the M, right here is M, this is where they did a core sample, and this is the planter box, so this shows that torque action I'm talking about, that when they drilled through here and took a core sample. This is where the butterfly took place down here, down this line right here where it says 20 feet, 20 feet, 20 feet, 19.6, 19, 19, 19. That's the offset. They're not 19 feet apart. They're showing you that at 19 feet, this is 6 foot offset. At 19 feet, this is a 9 foot 6 offset. At 19 feet, this one is a 9 foot 6 offset to this one. This is what this is identifying. At 19 feet 6 inches, weird, right? This is a 3 foot 6 inch offset. In reality, you think they'd want to say it 19 feet or choose 20, whichever one. If you choose 19, this becomes a 4 foot offset. And this gets greater. That becomes, let me see with my hash mark. Yeah, then it's 6 foot up. So it would be 4 by 6. These offsets are percentages. You can play with this stuff. This doesn't work out for me, no matter how I do it. The red line indicates the BMAs that I put in and how it would change. It would still fail in the triangular array system based on the offsets, because now I would use this one, 1, 2, 3, and 4, and these 3 as a panel. I would use these as a panel, use them panel individually or panel both times 2. I would see that the offsets don't work. And this is where everything goes south. So even though the cars are stressing here, there's a lot of stress here. This is just torqued crazy out here at the deck. This is just Torqueville. So this is just Torqueville. It's nasty. This side of it, not this side. This is a continuous wall, and these are set parallel from the wall. So I give that a pass, pretty much. And it meets it's 26 feet by 20. It meets 2-to-1 scale. So it can be ranged to be two-way, although I don't like the extra loading back here. There's a 19 opening. It's significantly more loading on this wall with the vehicles. And remember, there's 8 vehicles here, but at any one time, depending on how the parking is, you might have had another vehicle come down here and park, which puts 9 vehicles down here. And so that's a lot of loading here. Ending the video. Hopefully this is somewhat helpful, and I really hope you like the beginning, how I show how you can get the rotation, torque, the fracture line here, how you can get it to come down on the planter box, and get so get your fracture in the back and get your planter box rotation here. We're looking from the fireman side here. This is the walkway side, and that would be the planter box coming across like this is what I'm driving at, that one. And the causing all that rotation, all that. I'm going to load this one up today, Saturday. So you guys should have a nice, good one today. Take care. Bye.